Right, welcome back. So we're just going to do these three examples for this video. These are just slightly different examples to the previous ones, but if you struggle with those ones, I would recommend first understanding those before moving on to these slightly more advanced quadratics. And again, obviously, try to attempt these on your own before you watch the entire video. It's better to know exactly what to focus on rather than thinking that you know exactly how to do it just by watching. Alright, so there's two different ways that I would like you to think about this question. The first way is x squared minus 9 is the same as x squared plus 0x minus 9, okay? And the reason I'm showing it this way is because this will help you to visualize it similar to the previous video. So in this case, we would have a plus b is equal to 0, and a times b is equal to negative 9. And in this case, what you'll find is that the factors will always be 3 and negative 3 for this one. And what you'll also notice is that 3 and negative 3 are the square root of 9. Okay, so that's just important to note for a moment, and I'll go into a bit more detail in a second. Right, so basically, we're going to have negative 3 and 3, because 3 minus 3 gives us 0, so that test is checked, and 3 times negative 3 gives us negative 9, so that is checked. Right. So knowing that our factors are 3 and negative 3, we would write this as x plus 3 times x minus 3. And that's the conventional way to do it. However, there is a bit of a shortcut, and the shortcut is basically knowing that whenever you get a question like this, where it's just two terms, and you need to factorize, it's kind of hinting that this number over here is a perfect square. Okay, and if you find the square root of 9, you're going to get 3, okay? And what you'll find is that you can just put x plus 3 and x minus 3. So x plus the square root and x minus the square root in the brackets, and that will give you the answer. This is a good way to remember it and why it's true, instead of just memorizing a sequence to follow. But this is just a bit of a shorter method, and it is a bit of a trick that you can use to be a bit faster. But this is obviously important to understand before using this method. Another thing to note is that this piece over here has to be negative, right? So just as by way of showing you, let's suppose it was positive. Suppose we had x squared plus 9. Then this could be rewritten as x squared plus 0x plus 9. And we would have to find two numbers that add up to be 0 and multiply to be 9. So we can't really use 9 and 1 because those are very far apart and those won't add up to 0. So let's try 3 and 3. Those are going to add up to 6, and that's not 0, so that test case fails. If we tried negative 3 and negative 3, we get negative 6, and again that's not 0, so that fails. So because these are restricted to having the same sign, because this is a positive number, we can't use the same trick if this was positive, right? You can't actually really factorize this if you're using real numbers. If you use imaginary numbers, then sure, you can, but we don't really use those right now. So for all intents and purposes, this is not factorizable. It has to be a negative, right? So let's say we had x squared minus 16. Again, we have this hint just by way of the form, and we can see that this is negative. So let me highlight that. We can see that that's going to be negative. So what that means is that we're going to be having a case where this is probably going to be a perfect square. And we can check it. Perfect square. And the way we can check it is take the root of 16, and that's going to give us 4. So we're going to have an x plus here and an x minus here. And we're just going to insert 4 in the empty positions. As an exercise, I would like you to do this using the previous method where you represents it as x squared plus 0x minus 16, and see if you can get the same result using that method. Alright, so this is the last question, and before we start I want to first check, can I factorize this? Can I start factorizing immediately? And the answer to that is I actually can't because of this 2. Remember that we can only begin factorizing if we have a 1 in the x squared position. So let's see if we can factor out a 2 from every expression. So can we rewrite 8 in terms of 2? So we can write it as 8 times 2. So we can do 2 times 4x. That's supposed to be a 4. My apologies. Okay, and then can we write 10? We can write that as 5 times 2. So we can have the following. And then because we have a 2 outside of everything, we can take it out and just rewrite it like this. Okay, and now we can, for the time being, we can kind of just ignore the 2 and factorize what's inside these square brackets. Okay, so we have a plus b is equal to 4, and a times b is equal to negative 5. So some factors of negative 5, we have negative 5 and 1. We say negative 5 plus 1, that's going to give us negative 4, and that's not equal to that, so these are the wrong factors. What if we swap the negative sign around? What if we said negative 1 and positive 4? Then we get, sorry, negative 1 and positive 5, my bad. Negative 1 and positive 5, then we get negative 1 plus 5, and that's going to give us 4, and that works there. And if we say negative 1 times 5, of course that's going to give us negative 5, so we're good there. So we have negative 1 and 5 as our factors. And then what we'll do is we'll rewrite the 2 because we're just leaving it, and then we'll just proceed to factor as normal, x minus 1 and x plus 5. Now sometimes you'll have situations where you have to factor out a number before you can begin factorizing. It's quite normal. Here's another example of when you might have that. I'm not going to do the full example, I'm just going to show you how it would work. So if we had 2x squared, or rather 3x squared, we used the 2 already, let's be original, so 3x squared plus 48, so minus 48. If we divide by 3, we get 3 times x squared minus 16, and of course we know that we can factorize this because we did it earlier.